Hi everyone. Today we'll discuss more problems in current electricity. So you can see this question. A battery of 24 cells, each of EMF 1.4 volt and internal resistance 2 ohm is to be connected so as to send maximum current through a resistor 12 ohm. So here if you see, this is the resistance 12 ohm. So various cells are to be connected. EMF of each cell is 1.4 volt and its internal resistance 2 ohm. Now there are 24 cells in number. Now it says an internal is to be connected so as to send maximum current through a resistor of this. How are they to be connected? Means how should we connect these 24 cells of EMF 1.4 volt internal 2.0 ohm so that it gives maximum current through the external resistance 12 ohm. So when we say how these cells are connected, it means some of the cells will be connected in series and they will be connected in parallel. Okay, so let us consider this circuit. That some cells are connected here and some cells are connected here. Means some cells are connected in series, some cells are connected in series in the other row, and they are finally connected in parallel. So how many cells will be there in this row, how many cells were there in this row, and so on, so that the total number of cells that remains same, and that is 24 cells. So that we need to consider. So here, just to generalize the situation, if we consider, because we don't know how many rows will be there, how many cells will be connected in row, how many such rows should be there. So let us generalize, and we should consider that m number of cells in each row, and let there be n number of rows. Means n number of rows, 1, 2, 3, 4, 5 something up to n number, and in each row there are suppose m number of cells. So that m into n, that makes it how much? 24. Because m number of cells in each row, and there will be n number of rows. So m plus n, that gives you the total number of cells, that becomes m into this n, and that is 24. Resistance of each row, because in each row you have m number of cells and they are connected in series. So obviously the resistance will be how much? Each cell is having resistance of 2. So m number of cells, when they are connected in series, or their internal resistances are connected in series, so their equivalent, it will be how much? Twice of m, because m number of cells means m number of internal resistances. They are connected in series. So r plus r plus r m times. R here it is 2. So 2 plus 2 plus 2 m times, that makes this 2 ohm. It's the resistance, so it is 2 ohm, 2 m ohm. There are n such rows in parallel. So n such row in parallel. So it means the total internal resistance of the cell, therefore the total internal resistance of the battery, it will be how much? Now each of this, it is connected what? In parallel. In how many rows? In n rows. So 1 upon 2m plus 1 upon 2m plus 1 upon 2m n times. So that becomes what? N upon 2m. Again taking its reciprocal, so that will become 2 upon m. Yani 2m value of resistances are connected in parallel. So equivalent is what? 1 upon 2m plus 1 upon 2m plus 1 upon 2m. How many times? N times. So its equivalent will be n upon 2m. So equivalent, if it is suppose r, then 1 upon r is equal to this. So r, that will be equal to how much? 2m upon n. Here we have taken this r, so just to avoid any confusion, let us say it is r dash. So equivalent of all these internal resistances, suppose it is r dash, such that 1 upon r dash, it will be 1 upon 2m plus 1 upon 2m plus 1 upon 2m n times. So equivalent, it becomes n upon 2m. So finally, when you take this r dash, so reciprocal of that, that will give you 2m upon n. So finally we have this 2. So this is the total internal resistance of the entire circuit. Now the external resistance is how much? Capital R. So 2m upon n, 2m upon n, for the current I in the external resistance to be maximum, the condition is that the internal resistance of the battery must be equal to the external resistance. If internal resistance, if it is equal to the external resistance, then in that case it is maximum. I will just narrate how it is possible mathematically. It means 2 upon n, it should be equal to 12. and so this is one relation between m and n. Another relation is m into n, that is 24. Just simplifying these two relations, you will be able to get m as well as this n. Now why we are considering this equal to this 12? This is equal to 12, means here you have the equivalent of all these internal resistances, suppose R dash, and you have the equivalent this external resistance R, and here you have this cell connected. Okay, so now the maximum current through this, it will be when this equal to this. Why? Because when two numbers are divided equally, their product is always maximum. Suppose you divide 60 into 30 into 30, 30 and 30. So maximum will be how much? 30 into 30, that becomes 900. You can divide 60 in two parts, like let us say 45 into 15. So if you multiply 45 and 15, that is obviously less than 900. Similarly, suppose 40 and 60, that 40 and 20, that becomes 800. So it means when two quantities are to be divided so that the product is maximum, it should always be equally divided. So all these concept either we get from this arithmetic, or you can use the concept of maxima minima in calculus and you will be able to get it. So this is one thing. Another thing is, if you don't know this, and or if this does not struck in your mind, then we will strictly go according to the principle or the concept of the electricity, and that means the total resistance here, it is R, external resistance here, it is capital R, the current, let us say coming is I, then in that case current I, it will be equal to how much? E, this E, if it is E, divided by R plus this small r. Now small r, it is equal to 2m upon n, the equivalent of all internal resistances. External resistance, it is given. You will get this equation. Now use the concept of maxima and minima, because we need maximum current through this. Use the concept of maxima and minima. You will be able to get the value of this small m as well as this n, because current I has to be maximum, and current I has to be maximum, but this E is constant. Capital R and this R. This R, this capital R is also constant. You can't change this. But the equivalent of all these resistance small r, it can be changed depending on how we are connecting them. Whether we are connecting in m number of cells in each row, or n number of rows, or whether you are considering n number of cells in each row and m number of rows, or something else. So depending on that, this R we can have different values. So here variables are what? Variables are your I as well as this small r. Okay, when I and small r are variable, so it means just differentiating di upon dr. Maximize them. You know the concept how to maximize all that if you have studied this calculus, and you must have studied that. So from there, now again you can say this R will have two variables, m as well as n. So that one variable, either m or n, you can eliminate using these two equations. Mn is equal to 24 and 2m by n is equal 2m by n, that is equal to R. So R is equal to your 2m upon n, and Nm, it is equal to 24. So just either you replace m from here in terms of n, or you replace n in terms of m. So R will have only one variable, either m or n. Replace it here and then go for the differentiation. So you have to do all those things just to avoid all those things, because most of you must be knowing when numbers are divided in two equal parts, the product is always maximum. So just using, and that this concept also we get using the concept of maxima minima using calculus, or if you can get it algebraically or arithmetically also, we can justify all these things. So simplify this, you will get the value of m as well as n, and that will give you how many cells are connected in series and how many such parallel connections are there, or how many such rows are there. So here you can see this is the calculation part. So m by n, it is equal to 6, mn is equal to 24, so that m is equal to 12 and n is equal to 2. It means there should be 12 cells in a row and there should be 2 rows. So using this we can calculate, and that will give you the net EMF upon total resistance. So E upon R plus R, that we have just mentioned. Simplifying the current value, it is 0.7 ampere. Under this condition, this 0.7 ampere is maximum that will flow through the external resistance capital R. And if you want to calculate the potential difference across the capital R, potential difference is always equal to current flowing through that resistance into the value of that resistance. So potential difference across R, it will be current I flowing through this into resistance value. It has nothing to do with the internal resistance. When you are calculating potential difference across any particular resistance, it means the current passing through that particular resistance in multiplied by that resistance, that will give you the potential difference across that resistance. So from here we can calculate this. Now see this question. In the figure, each cell has an EMF of 1.5 volt. Each cell has an EMF 1.5 volt and internal resistance again 0.40. Calculate the total current. So now the diagram is there. So here you have 12 ohm resistance, this is 12 ohm, this is 18 ohm, and this is 36 ohm. Okay, and here we have this 1.8 ohm, this one. Now here cells are connected. So we have to calculate the total current. Now see the total current, because all these are resistances. Here also it is resistance. This is your EMF, and these are the cells, yani EMF. Every cell will have the EMF as well as the internal resistance. Internal resistance, it is given as for each cell 0.4, and EMF of each cell, it is 1.5 volt. We have to calculate the total current, means current flowing in this circuit. So suppose I1 current is coming from this side, let us say this one, and I2 current is coming from this side. Don't get confused, this side it is lower potential and this is higher. So why I am taking this? I am free to take any direction, that is my assumption, and once I get the value of that current, that will define whether this assumption is right or wrong. If I get this assumption with the positive sign, it means my assumption was right. If I get with the negative sign, it means the direction of the assumption it was wrong. Value will remain same of the current, but that negative sign will only imply that the current will flow in the opposite direction of my assumption. But as far as the assumption is concerned, we are free to take whether from higher side to lower side or from lower side to higher side, because the value of the current does not depend only on one cell direction or the cell EMF. It depends on the entire cell or all the cells in the circuit and their nature of connection. So here you have the cells connected in this direction. This is higher, this is lower. Here it is higher, lower, and so on. So these two are connected in parallel, these two branches, and finally here you have a cell. So now let us say how this situation will arise. So if we consider, suppose, current from this side and this side, so here you can consider the current I. This is suppose I1 and this is suppose I2. So I1 plus I2, that will give you I. So this is the total current I, because here this current I, again it will pass through this. Now this current, again this will get distributed in three parts. Some current to this side, some current this side, and some current to this side. Again, let us say it is I1, I2. So suppose it is I3, this is I4, and this is I5. Again, all this I3 plus I4 plus I5, again that makes it I. Again, this I, it will come here, and that will get divided, I1 this side and I2 this side. So this is the nature of the distribution of the current. So finally, we have to calculate the value of this current I. Now, let us proceed how to do this. So here you can say, all these cells are connected in series, and this is also in series, and finally in parallel. So let us calculate the equivalent resistance of this. Equivalent resistances of all this. So that will be how much? R1 plus R1 plus R1 plus R1 this side. R1 plus R1 plus R1 plus R1 this side, because each cell is having the same internal resistance. Finally, they are connected in parallel. So again, using the concept of parallel combination, you can calculate equivalent. All these cells are also connected in parallel, so again you can calculate equivalent. So equivalent of these resistances are known. Equivalent of this resistance, it is known. It means finally the current I, it will be equal to how much? This EMF this EMF and this EMF, yani equivalent of all these EMFs divided by the total resistance of this circuit. So let us calculate finally the total or equivalent EMF, all this, the equivalent resistance, then we will get I is equal to E upon that R, and we will be able to calculate the value of this current, total current. So here you can see, consider the total external R for the battery. So R is equal to how much? 1.8 plus 0.4 plus the equivalent of all this 12, 18 and 36. 12, 18 and 36, they are connected in parallel. So equivalent will be how much? 1 upon 12 plus 1 upon 18 plus 1 upon 36. Let us say it is equal to 1 upon R dash. Now simplifying and taking its reciprocal, you will get the value of equivalent of all this, and this is what it has been done here. Either you can do stepwise, you can directly put it, that is your choice. So equivalent of all this, it will be like this. Finally you will get this R. So equivalent of all these resistance, this plus this plus this, and it is coming as 8.2 ohm. Internal resistance of the battery. So internal resistance of the battery, that will be equal to how much? NR upon M. Again this N number of rows, M number of cells in each. Small r is the resistance of all. You need not remember all these things. All these things you can anytime orally, even without writing, you can calculate it. There are suppose N number of cells, let us say in this, or M number of cells. So equivalent resistance, it will be how much? MR of this. MR of this, if M number are also connected. If there are suppose M dash numbers, obviously it will be M dash into R. This will be M into R. Now they are connected in parallel. So equivalent will be what? 1 upon this, plus 1 upon this. Simplify and take its reciprocal, and you will get this. So there is no need to remember all these things. Whenever needed, you can always analyze yourself and you can simplify. So finally it is coming as 0.8 ohm. So this is 8.2 and this is 0.8 ohm. So net EMF it will be equal to how much? N number of cells here. And now you can see minus plus minus plus minus plus minus plus. So all these are having tendency to release current to this side, and they are also having tendency to release current this side, because it is from higher potential to lower potential, always from the higher potential. That is the tendency. Actually it depends on the overall nature of the circuit, all the cells taken into consideration as a whole, but for an individual cell, it is always from the higher potential towards the lower potential. That is the nature of the cell to release the current. So from there, if you simplify this, there are N number of cells, so equivalent EMF, it will be N into E. This is having tendency, actually we don't know, but tendency to release current in the opposite direction of all these cells. So it means NE minus E, that is equal to N minus 1 into E, and that becomes 4.5 volt. Okay, so the total EMF, it is coming as 4.5 volt. Total resistance we have calculated. So the total current, it will be I is equal to E upon that R, and simplifying you will get this value. So that you can see from here. You can see equivalent of this circuit, you can see here. 12 ohm, 18 ohm, 36 ohm, this is parallel. Okay, these are the parallel, and total current, it is coming as 0.5 ampere. Now again it has to be divided. So first let us see this calculation. So the total current, it will be net EMF divided by R plus this. Simplifying, we are getting this 0.5 ampere. Second part of the question is current in the 36 ohm resistor. Current in the 36 ohm resistor means in this resistor. So how to calculate current in this? So the total current now, it is known to us. This side it will get distributed. I1 suppose this side, I2 this side, and I3 this side. Okay, either you can use the Kirchhoff's rule, or you can say I1 plus I2 plus I3, I1 plus I2 plus I3, that is equal to total current I. Okay, all these are connected in parallel. So from there you can consider the relation, because there are three unknowns here. So only one equation till now we have. Now other two equations we have to develop. So as they are connected in parallel, potential difference across this, potential difference across this, and potential difference across this means between these 2 points, between these 2 points and between these 2 points it will be same. So potential difference across this, this and this, it will be same. Using that concept we can say I1 into R1 is equal to I2 into R2 is equal to I3 into R3. R1, R2, R3 are known to us. So this will give you another relations between I1, I2 and I3. Replace I2 in terms of I1 from here. You can replace I2 in terms of I1. So I2 is equal to how much? I1 R1 upon R2. R1, R2 are known. So you are getting I1 and this I2 also in terms of I1. Again I1 R1 is equal to I3 R3. So again R1, R3 are known. You will get I3 in terms of I1. You can substitute. I, it is known to us, that we have already calculated. Simplify, you will get the value of I1. Once you get I1, substitute here, you will get I2 as well as you will get I3. So all this you can calculate. This is the general method. Anywhere you can apply, wherever there will be a case of parallel combination. So either, and this is simpler method, directly use these equations and you can distribute the entire current into any number of parts. Here we are distributing in 3 parts, I1, I2 as well as I3. This is depending on, now this calculation here you can see, this is depending on what? Again you have to remember something. We don't want to remember anything. There are only 2 concepts that you need to always follow. One is the Kirchhoff's rule, first rule, second rule. Second is, whenever there will be parallel combination, the potential difference will remain same. Try to always make use of this concept. Whenever there will be series connection, the current flowing through all the resistance, it will be same. Only these 3 points you have to keep in mind. Then calculating the equivalent of all resistances, again distributing back. This method is always tedious as far as calculation part is concerned. It seems simpler that I will calculate the equivalent of all and I will get whatever is required. But the calculation part, it becomes very difficult. To have the calculation part simpler, you always try to get to the Kirchhoff's rule. Parallel combination means the potential difference remains same. Series combination means the current is same. Make use of these 3 concepts, and always you can justify, always wherever there is need of distribution, you can distribute easily. Where there is need of combination of that also you can do it. So generate the equation, circuit equation based on Kirchhoff's rule, and use these basic concepts. You can get whatever is required or desired. Just see here. Here again alternate method. That's what we are discussing. I2 is to I18 is to I36, I12 is to I18, I36. What is this? Again, we don't want this. These are only for the bookish purpose, you can say. We have written. But as a student, what you should do? I1 R1 should be equal to I2 R2, it is equal to I3 R3, because they are connected in parallel. That you always know. Potential difference will be same. I will compare and I will calculate of my own. Don't get confused from where we get all these relations. There is no need to write like this. Here it is written, in our lesson only it is written, but that is just to make you understand as far as the printing part is concerned. But once you apply your mind, always go to the concept, get back to the basics and always try to use it. I1 R1 is equal to I2 R2 is equal to I3 R3. From there, whatever relation you need, generate it, simplify, and you will get your correct equation. So instead of writing this way, we have written I1 R1 is equal to I2 R2 is equal to I3 R3. Here I am writing as a student, and that will be helpful for you. Here I am writing as a teacher. This is not helpful because you are convenient in this. So try to use this concept. I1 R1 is equal to I2 R2 is equal to I3 R3. From there you can say I1 is to I2 is to I3. That you can generate it in terms of R1 R2 R3. There is no need to go for that. Okay, I know this. Use the concept, get it done.